Hi everyone, welcome to Grade Up. In our previous lecture we have seen sets, relations, type of sets, and we also count relations, number of reflexive relation and all these kinds of things. In our today lecture we will be seeing functions, type of function, and solve few problem based on that. So let's start. So what is function? When I ask you a question that a machine is functioning properly, what do you mean by that? It simply means it's functioning properly. So suppose a waiting machine, there is a waiting machine and I am telling you that it is functioning properly. It means that when you go there and weight yourself, suppose it shows your weight as for 50 kg. Then after some time you go again and it is again showing 50 kg. It is not like that it will show 60 kg or 40 kg. Otherwise it is not functioning properly. So that concept is also there. How this concept is also there, I am telling you. So when this is a set A, okay, there are elements here. A function f from set A to set B is set for each element of A. When I am telling you that something is functioning properly, it means that for each element of it, it is showing only one value. For this element, it is showing one value. Suppose this is person 1, person 2, person 3, person 4, person 5, person 6, and we will be having these many here also, these values, and it is showing one value here. Okay, for person 2 it is showing this value. For person 3, can it show this value? Yes, two person may have the same weight, so it can be, it's fine. What if I told you that for person 3 sometime it show that value and sometime it showed that value? Then that is the violation of the function. Why? Because in functions we can assign a unique element to each element of A. To each element of A we have to assign a unique element. If you are assigning two values, that means it is not a function. It is not functioning properly. So that's the meaning of function here also. It is not different. It is same that we understood by the term that something is functioning properly. Okay. So how we denote the function? F is equal to A to B. F from A to B. So here A is the domain and B is the codomain. Range of function. What do you mean by range of function? So I told you that 3 should not map it. So I am crossing like that. Suppose 4 is mapped to this element, and then 5 is mapped to this element, and then 6 is mapped to again this element. So what is the range? What is the range? I told you this is domain, this is codomain, and range are all those for which we have an image. For suppose for one we have this image, this image, this image, this. So all these elements come to in image, but this is not mapped to any element, so it will not be in the range. That is the meaning. So range is always the subset of codomain. Range is always the subset of range of function f is always a subset of codomain. Okay, remember that. A function from A to A is called a function on A. So we solved a lot of problem on a single function. We define function from A to A, then we try to solve a lot of problem. So that is what means from A to A. Okay. Now we need to count how many functions are there. Suppose this is a set A. It consists 1, 2, 3, so on, n element. This is a set B. It consists 1, 2, 3, so on, m element. And now we need to count number of functions. Try yourself, it is easy. Okay. So for this one element, how many choices I have? I can map to any value. I can map to any value among there. So for this first element we will be having m choices. Okay. For the second element, how many choices we will be having? We will be having m choices again. Why? Why not m minus 1? Because in function, suppose if 1 is mapped to that element, then 2 can also map to that element. It is like that, 2 person having the same weight. It is allowed. It is allowed. Okay. So again m. Then for third person again m. And so on n. One thing is very important, that for each element in the domain we should have an image. For each element in the domain we should have an image. Otherwise what it will be like that, suppose you have a weighting machine, it show weights, but when a person weight 30, it does not show any weight, it show undefined or some error. So that should not be happening. Otherwise you will not say that it is working properly, you will say that it is not functioning properly. So for each value in the domain you should have an image. Okay, so how many functions are there? How many such m are there? The number of element we will be having in the domain. So that will be m power n. Okay, now why we are multiplying? Because we need to count the number of function, and it is in the like the product case. Product, we see the sum rule and product rule. So this is from the product rule. Okay, so number of possible function is m ki power n. One-to-one functions, and it is also known by the term injection. That term is important because many times they don't say one-to-one function, they will say that count injection. Many times they use injection, so remember that term. So what is one-to-one function? Suppose this is a set A, this is a set B. Now every element from this set is mapped to only single element. Every element from set A is mapped to exactly, or you can also say that 1-to-1 if no two elements in A are mapped to same element in B. No two elements in A are mapped to same element of B. If 2 is also mapped to A, then you cannot say that this function is one-to-one function. What it will be a one-to-one function? If it mapped to B and 3 mapped to C. This is one of the one-to-one function. So that is the meaning of one-to-one function. Now see, there is necessary condition for a function to be one-to-one. That is, the number of element in B means the cardinality of the set B should be greater than the cardinality of A. Can you justify it? Why it should be? So let's see. 1, 2, 3. Okay, and now I took pick A and B to only two elements. So number of elements in A is greater than the number of elements in B. Now you see that if I map this element to that, now I map this element to that, where should I map to element 3? If I map the element 3 to A, then it is not gonna be one-to-one function, but it will be function. If suppose I mapped 1 again to both A and B, then it is not a function. So I cannot have a one-to-one function in such a case. The number of element in set B should be greater than or equal to number of element in set A. Now we will count the number of function, one-to-one function possible. Okay, so we will take it like that again. 1, 2, 3, so n element here. 1, 2, 3, 3, so m element here. Now we need to count one-to-one function. How many choices are there for the first element? M choices. It can map to the any element, so m choices are there. How many choices are there for the second element? For the second element, you see that it cannot map to that element where 1 is mapped. So suppose 1 is mapped to 1, then 2 cannot map to 1. If it map, then it will not be one-to-one function. So that's why we will be having how many choices? M minus 1. Okay, for third one again, suppose 2 is mapped to this element, then 3 cannot map to this element and this element also, because if it map, then it violate the one-to-one function property, so it cannot map. So again we will be having m minus 2, then so on, and this is the nth element. See, this is for the first element, this is for the second element, this is for the third element, and what it will be for nth element, it will be like m minus n minus 1, and it will become m minus n plus 1, and this is the same formula as mpn. Okay, so it is same as that. Now onto function. What are onto function? So we will see, suppose this is a set A, this is a set B, and these are the element here, A, B, C, D, E. Now we will see if each element of B. So the word that is important is each. if each element of B is mapped to at least one element of A. So it should, okay, we will be having 1, 2, 3, 4, 5, 6. We should 6 here, suppose it like that. Okay, each element of B is mapped to at least one element of A. So if you should have, suppose 1 is mapped to like that, 2 is mapped to like that, 3 is mapped to like that, 4 is mapped to like that, and 5 is mapped to like that. Now each element of set B is mapped to some element of set A, then it is called the one-to-one function. Suppose E is not mapped to any function, then it is not gonna be onto function. It may one-to-one, but if suppose there is F and it is not mapped to anything, then it is not a onto function. Okay, the necessary condition is that the number of element in set A should be more than set B, more or equal to set B. So how you will say that? Suppose if I take the 1, 2, 3 element, and again I will take A, B, C, D, E. Now I write so many numbers because I know that it should be more, otherwise I am not able to map it. That's why I write it. Now I will show you how. Suppose A is mapped to 1, B is mapped to 2, now C is mapped to 3. Where D and E will be mapped? Where D and B will be? You said that okay, we will map it to 3. What's the problem in that? There is a big problem in that. Now it will not become function. How? Because when suppose we have a weighting machine and the third person stand on that weighting machine, then it is showing two output. One it is showing C and D. So that is not, it means that it is not functioning properly. So it cannot happen. Now D and E cannot be mapped to any element because 2 and 1, 2 and 3 are already mapped. So we cannot map D and E. So it will not be onto function. To map that we need to added more element here. So I will add 4, I will add 5. Now it will become number of element in set A to the number of element in set B. So that is what do you mean by that condition written here. Now question is asking number of onto functions. Okay, suppose this is A, this is B. Now here A and B both are having n element. Why I written n? Why not m and n? Because it will be complicated. We will see that case later. That is why I written that the number of element in A and number of element in B is n. 1, 2, 3, so n. 1, 2, 3, so n. Now this has to be mapped to someone. Now you can pick any element, and this has to be mapped to someone. But we have to make the function onto. So for this one we will be having n choices. For the second one we will be having n minus 1 choices. Why not n choices? Suppose you map it to 1, then what will happen? It violated the property of function. It will not become the function. So always remember that every element here should have a unique image in set B. Okay, in set A every element should have a unique image. So we cannot have n choices for second element. We will be having n minus 1 choices. But why I am taking from that side? Because I know that every element will be having an image, because I am counting onto function. Otherwise there may be a chance that 3 will not be mapped to anyone. But I am not considering that. I am counting the number of onto function. For that every element from set B should have an image in set A. Okay, so it is also mapped to someone. We will be having n minus 2 choices, and so and for the last element we will be having 1 choices, because there are n element in both the set. So what is this? It is n factorial. So that is the number of onto function when the cardinality of set A and set B is n. Now we will learn bijection. What is bijection? So when a function is one-to-one and onto also, then it is called bijection. Or I can say that term also, when a function is injective as well as surjective, this term surjective, then it is called bijection. So remember this term because questions are framed using this term. So you need to remember that. A function from f to f is called bijection if f is one-to-one as well as onto. So it should be one-to-one as well as onto. So let's say example here 1, 2. Now we will be considering the finite set. I am writing 1 2 3 4 5 and A B C D E. I have written something here. When A and B are finite set, then bijection from A to B is possible when both are having the same number of element. Both are having the same number of element. What will happen if they does not have the same number of element? We will see. So now our function should be 1 to 1 first thing, and then it should be on to. For 1 to 1, 1 can be mapped to 1, possibility. Second can be mapped to second element. Second can be mapped to second element. Third can be mapped to this element, and fourth can be mapped to this element, and fifth can be mapped to this element, because we need to make sure that it is 1 to 1. So fifth cannot be mapped to already mapped element. Fifth cannot map to D, so it has to be mapped to E. So now suppose if there are more element here, suppose like that F, then what will happen? You need to then suppose 5 has to map to that one also, then it will violate the function property. So this cannot happen. Okay, suppose there is one more element 6. Now this 6th element, what you will do? Every element has already mapped down. What will you do? When you try to map it to someone, then it will violate the 1 to 1 function property. So you must have both, the cardinality of both sides should be equal. Cardinality of both sides should be equal for a function to be bijection. Now I ask you a question, very simple question. Suppose this is equal to n. I ask you the number of bijection function possible, the number of bijection possible. So can you answer me? That is very simple. Number of bijection. So for this element we will be having 5 choices. For this element, second element, we will be having 4 choices, and so on, and they are also equal. So it will be 5 factorial. So these many is the answer. So here we are taking n, so it should be n factorial bijection are possible. Now example on bijection. Let A is equal to R minus, so this is the real number. This is for real number, and we are excluding R. A cannot be is equal to, okay, it is the domain. Set A, in set A we cannot have an element 3, okay. In set B we cannot have an element B, okay. A function from A to B is defined as like that. Which of the following is true? You need to ask whether it is 1 to 1 and on to. For 1 to 1 in set A we will be having many element 2, and also it is real number, so 1.1, 1.2 and so also, but 3 is not there. 3 is not there. I am writing as like this course, okay. So now these many element will be having here. So how to find whether it is 1 to 1 and on to? So for that what I will do that, suppose there are 2 element which are mapping to the, suppose there are 2 element in this set that are mapping to the same element. There are 2 element that are mapping to the same element, okay. In set A there are 2 element that are mapping to the same element. So I am considering that F is equal to FB. So I write it A minus 2 and like this. And when you try to solve these equations, what will you do? A minus 2 and B minus me 3 is equal to me A minus me 3 and B minus me 2. Okay. Now you will do AB, then you will do 3A, then you will do minus 2B, then you will do plus 6. Okay. Now if you solve it here, what you will get? AB, then you will get minus 2A, okay, minus 3B, and then plus 6. We get that from the right side. Okay. If we get A and B as not same, that means that it is not 1 to 1, because we will see. So here you see that AB will be cancelled out, 6 will be cancelled out, okay. Now 2A, okay. Now this 3A will come here, it will become A, and this it will go here, then it will come. So it is saying that A and B are equal. So there are no such number possible. If there is, so I take it, it is like the proof by contradiction. I say let it be happen 2 numbers such that they are mapping to the same element X. And when I try to find it such these 2 numbers, I will find that they are both equal. So there is no such element. That means there is no such element. It is 1 to 1 function. What we will do to prove that it is 1 to function? So this is an image. It's suppose an element is mapping to here C. I write it as C. Now I will try to find C, I will try to find x in term of C. So when you try to solve it, you will get this. X is equal to 3C minus 2 and C is minus 1. Here C cannot take the only value that is 1. And in our domain, in our codomain, we have not 1. In our codomain, we cannot have 1. So C can take any possible value. So for every value of C, there is an X. That means it is onto function, because we will be having for every value here C cannot be 1 by this, and also we will in our codomain C is not equal to 1. So every element here can be mapped. For every element we will be having an X. See this GATE CSE 2015 questions. It is asking the number of onto function from set this to set this. Now how will you do it? I told you that if the number of element in set A is equal to n and set B, we saw the previous example, that was easy. But now it is tricky, little bit tricky. So we need to find 1, 2, 3, 4 and A, B, C. We need to find number of onto functions. Okay, in number of onto function, everyone should be mapped. Everyone should means that every element of set B should be mapped to some element of set A. That is the thing that we need to take care. Okay, now I will ask you, what is the total number of function from set A to set B? You should answer that. I told you in the previous slide. So that it will be, for this element we will be having 3 choices, for this element we will be having 3 choices, for this element we will be having 3 choices. So it will be 3 to the power 4. So that is the number of function we will be having. Now what we are trying to that, from these many function we are trying to remove those function from where you will not map to A. You will not map to A. Okay, you didn't map to A. So now I just consider that I have removed A. Now how many functions you are there? Because I am trying to subtract all those cases where we didn't map to A, because that should not be happened for a function to be onto function. So that's why now this function will be having 2 choices, this will be having 2 choices, and this will be having 2 choices. So it will be 2 to the power 6. It will be 2 to the power 6. Now it can happen with B also, then it can happen with 3 also. So I am selecting 3C1. 3C1 means that from this element I will pick one element and I just mark it as block and I will not count it in my study. Then I will try to find the remaining function, that it will be 2 to the power 6. So it will be 3C1 into 2 to the power 6. Now one thing is left. What is left? Can you think it? The left is that when any of these elements cannot map to both element A and B, now we need to count that also. Now here the concept of principle of mutual exclusion and inclusion will come. How? I will tell you. So this is the total number of function. Okay, this is the total number of onto function we will be having. Now I have counted that these many function that does not map to A. We mark it as and we try to, so A is completely separated. Similarly I counted for B and similarly I counted for C. Now I am telling that I have left the case when both A and B are left, this case. But if you see that this case is counted twice. How it is counted twice? Here I counted twice for A and here I counted for B. I counted that case twice. So I need to subtract it. Instead of subtracting, I need to add it. Instead of subtracting, because we are subtracting total from total, these which are not, I need to add it because I cannot count it twice. I need to count it once. So I am adding that. For that I can say that like pick any 2 element, 3C2. Now see, suppose I picked A and B. Now how can we that mapped? For this element we will be having one choice, for this element one choice, for this element one choice, for this element one choice. So that will be 1 power 4. Okay, so these many are there. Now I write it 3C2. Is it considering all the case? Yes, it is considering all the case. From 3 element you can pick 2 element. AB for AB portion, that is for BC that portion, and for AC that portion. Now there is something that is missed. Now when I remove that, this also and this also, by doing addition I am actually removing in a different way. Okay, now when I remove this middle portion which is there in all three, I have what I have done it, I removed from here, I removed from here, and I removed from here, and I counted here, counted here, counted here. So 3 times counted, then 3 times removed. So it is not counted actually. I need to count it. So I am doing it like 3C3 when none of the element I choices. So it will be 0 power 4. So it will become 0. So that is 0. Now what is 3 power 4? That is 81. Now 3C1 is equal to 3 into me. This is 2 power 4. So 2 power 4 will be 16 minus this 3C2 is equal to me 3. This 3C2 is equal to me 3. So 81 minus 48 plus 3. So it should be 84 minus 48. It should be 36. So that is the number of onto function. So you need to count it in that way. It is easy once you do 2 or 3 times practice, because it required practice. Do at least 2 to 3 times practice, and then you will become familiar of this thing and you will solve it. And this type of questions come recently, okay, and they asked again and again such type of one by twisting the question. So how can you make sure that you will attempt correctly? By practicing. So try to practice a lot. There are a lot of example in Rosen, so try them. Okay, thank you.